Today, we are going to study about how to write chemical formulae for simple compounds. The simple compounds which we will be dealing with today will be containing of only two elements. So they will be called as binary compounds. So let us start with the most easiest example of hydrogen chloride. So first is hydrogen chloride. The very first step is to recognize which among these two is the cation and the anion. That is one which consists of positive charge and the one which consists of negative charge. So for this, we have to know the symbol and the ionic charge of the individual elements. So here the first step is to write the symbol of the respective ions. Here the positive one, hydrogen, is known as the cation and chloride is known as the anion. The symbol of hydrogen is H and chloride is Cl. The next step is to know the valencies of the individual ions. Here the valency of H is 1. The valency of Cl is also 1. So you have to write the valencies of the individual ions H1, Cl1. After writing the valencies of the corresponding ions under them, we have to go for crisscross method. This crisscross method involves taking the valencies of the opposite ions to the particular ion. Here H will be matched to 1, Cl will be matched to 1. And the final compound which we will get is H, the corresponding valency to be written as a subscript 1, Cl 1. But in chemistry, usually when we write the formula, we do not consider or we do not take the valency 1 while writing the final formula. So this would be equivalent to writing HCl. Here it is understood that H number of atoms of H is 1, Cl is 1. So this was one of the most easiest example among all. Let us move forward and take a particular compound in which we have valency 2, 3 or 4 involved. So the second example would be hydrogen sulfide. Now you guess among hydrogen sulfide which one is the cation and which among this is the anion. Yes, you are right. Here hydrogen is the cation, sulfide is the anion. Hydrogen having a valency of 1, sulfide 2. So you yourself can work out. So the first step is to write the symbol. Hydrogen being H, sulfide, that is sulfur, being S. The valency of hydrogen being 1, sulfur being 2. Next step is correct to crossover. So H is matched to 2, S with 1. And the final formula comes to be H, 2, S, 1. But as I said, we need not write 1. So this would be equivalent to H, 2, S. So the final formula of hydrogen sulfide is H2S. Here the subscript 2 always indicates the number of atoms of that particular element. So here 2 means there are 2 hydrogens in this particular compound and one S being valency of means S has a subscript of 1 means there is only 1 atom of sulfur involved in this particular compound. So this is how you write chemical formulae for different compounds. Not only this, we can take the examples of various other. For example, carbon tetrachloride. Carbon tetrachloride. In carbon tetrachloride, we see which is the anion and which is the cation. Carbon is known as the cation, and chlorine, being the anion, belong to group 7. Here the word tetra has come. Here tetra means 4. Right? So, first step as we go, symbol. Carbon, what is a symbol? C. And chloride? Cl. Then valency. Valency of carbon would be 4, exactly, because it requires 4 more electrons in order to complete its octet state. And chloride would be 1. Again go for criss-cross. Criss-cross. So we end up with C1 Cl 4. But this would be equivalent to writing CCl4. So, do you now understand why the word carbon tetrachloride? Because here number of carbon atoms present is 1. Correct. So, number of C atoms present is 1 and number of chloride atoms present is 4 that we can see from the formula. That's why the name carbon tetrachloride. So this is how we can write chemical formulae for different compounds. You yourself can try for Al2O3 or MgSO4, or you can even write it for different compounds like magnesium chloride. We can work it either ways. Either we can write the formula and try to know the chemical name of it, or we can write the chemical name and try to find the formula for it. So now, friends, we are going to use a different method to understand how these chemical formulae can be written. Let us take the example of aluminium chloride, or better we'll take the example of aluminium oxide. Okay, so in aluminium oxide we know that aluminium consists of valency 3. This means that it has total 3 valency legs. So this is basically known as an ice cream stick model. So in this ice cream stick model, we'll be understanding today how to write the chemical formula of aluminium oxide. And here we know oxygen. This is oxygen. Oxygen, the valence of oxygen is 2. Exactly. Because to complete its oxidate state, it requires 2 more electrons in its outermost shell. So, first we have aluminium. Aluminium has a valency of how much? 3. And oxygen has 2. So, if we try to now combine aluminium and oxygen, what do we see here? One of the valency of aluminium remains unpaired. It is not matched with anything. So what do? We go on for taking one more oxygen. Okay, let us attach one more oxygen to it. Oh, what is the problem which we are facing here? Again, one of the legs of oxygen is not matched with any of the other legs. So what do? Take one more aluminium. Okay, so attach one more aluminium to this. But there is again a discrepancy here. What is the discrepancy? The 2 valencies of aluminium is not being satisfied. So what do here? Exactly, you are right. Let us take one more oxygen. So here we go, taking one more oxygen. So are all the valencies of aluminium and oxygen satisfied now? Yes, they're satisfied. So the formula comes out to be Al, symbol of aluminium, Al, oxygen being O. The valency of Al being 3, oxygen being 2. Criss-cross. So the final formula for aluminium oxide forms to be Al2O3. So this is aluminium oxide. Is it the same which we got in our ice cream stick model? Yes, there are two atoms of aluminium and there are three atoms of oxygen. Hence the formula Al2O3. This cannot only be explained by this method. There's another interesting method. Do you want to know, friends? Yes. So let us now try to use the valency tiles. Okay, so how does this valency tile works? This is calcium. Calcium has a valency of, we know, 2 plus, right? 2 plus. So it is in valency is, charge is 2 plus and the valency is 2. So it is a requirement of 2 more electrons. So which is the person who is going to donate 2 more electrons to it? Let us take today's anion to be sulfate. Sulfate has a valency of 2 again and a charge of 2 minus. So sulfate has the capacity to give 2 electrons and calcium has the capacity to take 2 electrons in. So can these two combine somehow to form a particular compound? Yes, you can consider this to be the key, calcium being the key. And here, there's another one which can interlock with it to form the compound. Calcium taking in 2, sulfate providing 2 electrons. So, our compound which forms is calcium sulfate, right? Okay, why only this? We can take many such examples. Let us see magnesium. Magnesium also has a valency of 2 and a charge of 2 plus. Is there any other anion which you can think of which can form a compound with this? There are so many, right? Let us take oxygen today. Oxygen again has a valency of 2 and a charge of 2 minus. So, we take oxygen and can we link these two in a way where it can form a particular compound? Yes. So, it forms MgO2 minus, right? Exactly. So this is how we can use different compounds in order to form the different chemical formulae. So this is it, friends. For any more queries, please continue watching my video for the next sessions. Thank you for your patient listening.